Hello, students, and welcome back. I am excited to say that my software is working properly, and so I'm back to a better quality of video for you. So I'm going to have you refer back to your homework 11, and I went ahead and chose 3 problems that I thought maybe we'd take a look at to see if you discovered the power rule that I'm getting ready to show you for today. So problem number 9, your original problem was 3t minus t to the second. And when we did the derivative, we got 3 minus 2t. And for number 18, we started with f equaling 2 minus x to the second, and f prime turned out to be negative 2x. For number 27, f started out as x to the third, and f prime became 3x squared. So I'm wondering if you see a pattern. So maybe pause the video for a little bit, think about it, and then we'll come back and look at the power rule. So if you took a little time to think about what the pattern is, the power rule has to do with the exponent and the coefficient in front of your variable. So we'll use this notation, the derivative with respect to x of x to the n power. What happens is the power becomes the coefficient. You keep the variable, and the power for the exponent reduces by 1. So the power rule is for an exponent, x to the n, the derivative is n times x to the n minus 1 power. And then you might have noticed that there are some special cases of this when the derivative is taken just of an x, that is 1, although that does follow your power rule. I'll do that over here. So if you do the derivative with respect to x of x, and you use the power rule, your exponent is a 1, so a 1 would become your exponent, and then it would be x to the 1 minus 1 power, and that would be x to the 0 power, which is 1 times 1. So you get 1 without having to show all of that work. So that's your power rule, and you could take a little shortcut for that if you're doing the derivative of just an x, its derivative is 1. And then likewise, you've got the derivative of a constant. So the derivative with respect to x of a constant is 0. So you may have noticed that in your opening problems, anytime that there was just a constant, like in number 18, the derivative of that constant just became a 0. So as we look down here at the derivative, the negative 2 came as from the exponent on the x, and then this 2 at the beginning, its derivative was a 0. So there are some other patterns and rules that you can follow. If you have a constant that you can factor out of the function first, you can do that and then do the derivative of the function. So you can do the constant factored out. Sometimes that's easier to do, and then do the derivative with respect to x of the function f of x. And remember that we have all these different notations that mean doing the derivative. So when I'm using that d dx notation, that's the same as me asking you what is f prime of x. The third rule goes with sum and difference. I think you'll do this one very naturally. If you have two functions added or subtracted together, The derivative can be done kind of like doing the distributive property. So you can do the derivative with respect to x of the first function, and then plus or minus the derivative with respect to x of the second function. So in other words, you can just do the derivative throughout the summation process. And then we'll just look at the first two trig rules for today. We'll add the other 4 on in another lesson. So the derivative of the sine of x is the cosine of x, and the derivative of the cosine of x is negative sine of x. And you'll find that anytime you do the derivative of one of your trig functions that begins with the prefix co, so if you're doing a cosine, a cosecant, a cotangent, anytime you have a co, the derivative will be negative. So hopefully that'll help you remember the derivative of cosine is negative sine of x. So those are your opening rules. And then at the bottom of page 1 of your notes, we have a couple of statements that I'd like to go over with you. So I'm going to try to clear this ink and then scroll up. So just something I want you to know is that the derivative is a function for determining the slope. So that's what goes in this first blank. The slope of the tangent line to the graph of f at a certain point on the graph of f. And one of the more important types of lines that we will be looking at will be horizontal tangent lines. And I'd like for you to remember that the slope of a horizontal tangent line, or of just any horizontal line, is 0. And so if you think about why that might be important, if you would look at, I'm going to have you draw an XY axis. If you look at a graph, and on that graph, maybe draw a function that would have some maximums and minimums. Right at a maximum value, you would have a tangent line whose slope is 0 because it's horizontal. And right at the minimum, you would have a tangent line that is horizontal and again has a slope of 0. So having a slope of 0 on a tangent line can be an indicator for a function that you have either a maximum or a minimum. And that starts to add value to knowing how to find the slope with just one point. So this will be the introduction to your shortcuts, and we will work on some examples for the next video.